Welcome everyone to another RSE seminar. This week we're delighted to have with us Samantha Finnigan from Durham University. So I believe they were initially an RSE at Newcastle University before moving over to Durham as a senior RSE, and they are now the RSE team lead over there. And they're going to tell us a bit about their pet project today, which is SerialKVM.
Thanks. Okay, let's try and take this off so you can actually see the screen. Right, so yes, thank you for that introduction. So I guess you know who I am already. Can we go to the next slide? Yes, we can. Okay, so this whole kind of project came about through another project which I'm involved in called Carpentries Offline. And Carpentries Offline is sort of associated with the Carpentries, you'll know them, and asks the question, how do you teach computational skills in areas where you don't have good or reliable internet access or even potentially electricity? As an example, Indonesia is the 14th largest country in the world by landmass, almost as big as Mexico, and it's 17,000 islands distributed over an area of a similar length. Is it longitude? The long one, the one that goes around. As Dublin Island to Astana, Kazakhstan. So quite a geographically distributed area. So it's kind of the brainchild of my colleague at Newcastle, Janetta Steen, which came out of a SSI collaborations workshop hack day, where they came up with this kind of solution of doing workshops, carpentries workshops, on battery-powered local hardware, and was then supported by an SSI fellowship, which was awarded to Janetta. There's a few different projects under this sort of Carpentries Offline banner. There's the bootable flash drive, which is a Linux image with some pre-installed Carpentries content. There's the same sort of thing, but as a Raspberry Pi micro SD card image, so you can just pop it into a Raspberry Pi, boot that up, and get a Wi-Fi access point, a Git server, and then be able to follow the interactive lesson material on a local instance on a local server. There's an offline data side Python package, which is brainchild of Vernalise Cruz, who's another person involved in this project, which is a pip package which you can use to mirror package repositories from R and Python, and mirror teaching materials locally. And then finally the mini HPC, and that's sort of the bit where this project kind of attaches in to this ecosystem, which again, Janetta, looking at teaching HPC and always noticing things going wrong. There's always people who come along and they haven't registered an account on the HPC you're trying to use. There's always people trying to run processes and login nodes. There's always network connectivity problems for external people, trying to get onto Edge your own, things like that. And the base fact of that HPCs are not easy things to set up. So this takes us to September 2023. Which some of you may have been there actually in the room or online, which was the Carpentries Offline workshop at RSECon 23. So that was where we were hacking this sort of early iteration of the Carpentries Offline and the HPC, which is not quite as mature as the current one, which you can see on the slide with the banana for scale, 3D printed banana for scale, and that was using. There's a couple of different iterations of the mini HPC, but the one we were trying to hack on, or my hack group were trying to hack on, was using this sort of Rock Pi 4C hardware, which Janetta was able to buy with SSI funding. So there's again single board computers, much like Raspberry Pis, but a little bit more powerful, so little bit different things, and mostly because actually in 2020, 2021, when this project was kicking off, it was actually impossible to get hold of Raspberry Pis anywhere from anyone. So yeah, looking out to other manufacturers So my group were trying to get Pixie Boot working on these things. Network boot, take an image from a server, load it up, boot that image. But network access wasn't pre-configured on these things, and we had kind of this single screen and a monitor and a keyboard, which we're kind of sharing around between different people, plugging it in, unplugging it, trying to sort of debug these things, get them attached to the network, wait for other people to finish their bit. It wasn't really working out. And I went, look, there must be an easier way to work with these things than this. So that kind of brings us to the premise of this project. Carrying around bulky hardware, monitors, keyboards, when you're working with Pis and other single board computers is unwieldy, unreliable, and really honestly takes the joy out of it. But if you're coming to kind of invent like a hackathon, you probably already brought a laptop with you. Seems like sort of the minimum thing people carry around with them. So why can't you use the tools you've already got? Because laptops have got a screen and a keyboard in them. Although they don't have a way to pass those through to other devices natively. You can get things like KVM crash cart adapters. You can buy these. StarTech makes one, but it's like £500. Yeah, it's aimed at IT professionals in data centers. It's really not something which a hobbyist would reasonably be able to access. So the question I asked is can we just build something for less than £500? And the answer, I think, is yes. And this was my first prototype. So image on the left-hand side of the slide there, very first prototype. That's a serial port. And that's a webcam to the host computer. But to the guest computer, it's a display output and a keyboard. And that's kind of the foundational hardware layer of how it works. So human interface devices, HID devices. This is like mice, keyboards, touch screens, things like that. And I was kind of playing around with bits of hardware I already had. I don't know if anybody's ever tried bit banging the USB protocol on a single like chip like an ESP, but it was pretty hard. Timing issues. You might have heard of the USB rubber ducky. That's like a penetration testing tool. It's a USB stick that you plug into a victim machine that has a payload on it, and it pretends to be a keyboard. So it might run like Windows R, run a command in the run box, and then go to a website, download a payload, run the evil payload. Yeah, so quite a useful tool for that. So I was sort of thinking about that, and I did some sort of searches for things which might be able to do this, and I came across this CH9329 chip module, which is like a serial port to USB HID device on a single module there. And for this, like eBay and AliExpress are the perfect kind of things just for getting your kind of first development hardware together. And you can get the major components of this for less than a tenner. So 235 plus 179 delivery from China for that module, 599 for the lowest quality HDMI capture USB thing in the world ever. But for sort of debugging and trying to start building something, it works, right? You don't need super powerful hardware. So yeah, obviously like higher quality HD capture cards are faster, but that got me going. This like little P-way video capture thing. So the first iteration of this prototype, how do you get the video into the computer? Well, it's just a webcam, and VLC can load up a feed from a webcam and display it. So that was what I had. Open capture device from the menu there, and you can see instantly the display output from your like Raspberry Pi or whatever on your laptop screen. Okay, great. Step one, good. Step two is slightly more difficult. So this CH9329 thing. So the first thing that I do when I'm working with a new integrated circuit is I go and find the data sheet, because generally the data sheet has all of the information you need to know in it. You go and read it. Lots of information in it about working with the electronics. If you want to like design a board with this, it'll tell you what the kind of impedances for the resistors that you need to put on it for the serial port are, but it won't tell you anything about the protocol that speaks, which was really annoying. And I couldn't find any information online in English at all two or 3 years ago, or even in like Google Translate Chinese on how to talk to the thing. So I've got this board which claims to do a thing that I want to do, but I like how do you talk to the thing? So searching around a bit more, I found somebody in China had written a little existing implementation. So there's this ch9329com Python package by Beiji Xiao on GitHub, designed for scripting. It's not really like what I wanted to enable this project, but it did have a little implementation in it where I could figure out the thing that you need to send to this thing is a 2-byte header with some magic numbers in hexadecimal, send 57AB, an address, the command, the length of that command, some data, and a checksum. So, you know, that would have taken me ages to figure out without that. And then figured out what some of the commands that were available were. So sending OXO2, it's a keyboard command, a USB HID keyboard packet. Sending 04 was a mouse position in absolute coordinates. You can do like relative coordinates with OXO5, which seems like scrolling. So the next question is, okay, so I've got some like sample code. How am I going to get the input from my laptop keyboard into it? And it turns out there's several different methods to capture keyboard input using Python. So again, Stack Overflow is your friend, good starting point. And I found sort of several different ways of doing it, several different kind of modules that were available. I didn't know what the comparative affordances between all of them were. So I implemented all of them in sort of an importable way based on an abstract basic class. So I've got a little program interface now, and I can just let the user choose which one they want to use with a command line switch when they run this script. So I did 4 initial implementations. I did PyUSB, which is a low-level USB handling library for Python. I did TTY, so terminal, standard sort of terminal thing. PyInput, which is sort of an input capture library in Python, and cursors, which is sort of your like terminal line mode graphical library. So essentially what I'd written was a keylogger. And it turns out operating systems have protections in them against doing things like writing keyloggers. So these different libraries do different things on what you need to do. So PyUSB, it does things like capturing modifiers, so Control-C, Control-V, sort of fairly standard thing you might want to do, that it'll capture those, pass them through. But you can't paste from the host to the guest because you've captured that Control-V. It's been sent through to the guest. It's not gone to your system. PyUSB is actually just literally hijack the USB interface of the device that you're using. Actually, it needs root to work at all. It needs pseudo permissions. And the way it's working is it's unbinding that device from control of the operating system and allowing your script to access it instead. So really low level, sort of like a bit intrusive, not really what I want. People aren't going to be comfortable running stuff as root. That's not great. So TTY, that's okay. You can't do modifiers like Control-C, Control-V, but you can paste into it. So you can paste your text into it. This blocking column means that while you're using it, is that input only going to your script and nowhere else? So is it blocked from the rest of the OS? And then the way that you exit, either Control Escape or Control C. So anyway, so I kind of hooked it all together and I stuck it on GitHub. And yeah. So how does this thing work then? So let's think about keyboard scan codes. So you've got a keyboard. Here's a keyboard. Let's hope it doesn't hijack the monitor. So you're going to press a key on that. And that keyboard is going to send a scan code. Now, this has been keyboard scan codes have been around forever, but they're subtly different now because it's actually a USB HID report, which is different to a PS2 scan code. But actually, it's 8 bits, not 7 bits. But the things like the number allocations that are on the graph at the top, subtly different. So I think like F2 key, it's 0x59 in hex on USB HID report, but it's 0x58 as a PS2 scan code. So that confused me for a bit. Until I figured out I was trying to send PS2 scan codes instead of USB HID stuff. So that was kind of interesting. So what does a USB HID report look like? Well, it's 8 bits long, 8 bytes, sorry, long. And byte 0 is like your bit field for your modifier keys. So if you press your control key, it sets a bit. If you press your shift key, it sets a different bit. And those bits are logical and bit together. So you see A just sends sets byte 2 to 0x04. And you press control, you've added the modifier of 0x01, it's set 1 bit in that bit field. And it's also sending A, and then underneath my captions box for those in the room, if you press control and shift, it's mapped them together, it's added them together. And if you press more keys at the same time, it adds them to this sort of queue. And as you release them, they sort of pop off the beginning of the queue. So it's quite elegant, actually. It's quite a nice little thing, and there's lots of documentation online about it. So where are we? Focus back to that. Some of these sort of classes needed their own mappings. So PyUSB was really easy because what you're getting into PyUSB is keyboard scan codes. So keyboard scan code in, keyboard scan code out. Great. Not so great. TTY it's just going to give you an alphanumeric character of whatever key you pressed. So it's kind of like an ASCII representation of that you can take, and then you can kind of push that directly through. But then things like curses give you literally a string of the key that you pressed. So now you need a mapping to map that string into the right scan code. PyInput has like its own enums, which you can also map. So a little bit extra work to support kind of different kinds of thing there. So that's not actually a terminal. If I can find my terminal. I will drag it over and try and run this thing. They say never do a live demo. Find out whether, oh, there we go, whether that's the case. Okay. Is that it? Is that, oh gosh, it's a lot smaller than that one. Let's try and blow that up. There we go, something like that. So yeah, this is kind of the first implementation. I've got this control.py script here. Oh, it's not there. It's under KVM serial. Okay, great. So we've got CH9329 control script with some options. Really quite basic, but you know it's there. We need a port which is on Mac OS X is quite similar to the Linux option of still too many. Trying to type and look at what you're doing on the screen behind you is quite difficult, actually. cu.usb serial 001, that's the one. Okay, so by default, it's gone into cursors mode. So if I'm pressing A, it's actually sending through A to the device on the other side. And I just press escape to exit. Let's put some verbose logging in there. Let's do -v. Aha! So now we can actually see the scan code that's going over. So I press W. OX77 is what I've got in from TTY, but that needs to be mapped to OX1A for the keyboard scan code, which is 26 and decimal. So you kind of get the idea there. Let's put that away. Do it. Next slide, please. Okay, so that's what I did, and then I forgot about it for 2 years. So, you know, I kind of hacked this little script together. It served the purposes that I needed. I had my VLC window up. I had my little keyboard capture script. I could send stuff over the connection, and I left it alone. And it sort of started accruing stars on GitHub. Oh, that's cool. People are using it. And then somebody added a pull request, and it kind of just sat there until I needed it again in April of this year. So there was some stats. So people are cloning it. That's interesting. Oh, it's like 94 clones, 56 unique clones, 51 visitors. I don't know whether any of this is kind of like capturing automated traffic or anything like that, but it's kind of interesting. And GitHub gives us like the telemetry for public open source projects. Then I was kind of Googling around, and oh, there's a post on the FreeBSD user forums. I've never used FreeBSD. I know that OSX is vaguely related to it. It's interesting. Oh, why don't you try using this script? Thanks, it works. Ah, cool. So more people are kind of realizing this chip exists. But at one stage, my repository was the top hit on Google if you Googled that chip, because it was like the only one in English. So there we go. So yeah, as I said, I got a pull request. So Redneb on GitHub, I don't know who he is. He's some guy, or they're some person, I suppose. So this pull request adds support for function keys to the cursor's backend. So I haven't supported F keys. Oops, my bad. Here's a pull request. So they took the code. They found it didn't quite do what they wanted. They altered it and they contributed it back. So I love open source. This is great. So yeah. So in April, I sort of went, oh, yeah, I could do a little bit more coding on this. Sounds fun. So how can we sort of professionalize this and make it a bit more usable for people? So how people are using it, but how can I make it easier to use? So at that point, we've only got this control.py thing, one tool, one script. So I was like, oh yes, and let's think about what features I might want. I might want a GUI. I know this thing supports mouse capture, so you know if people are using a guest machine with a mouse, they might find that useful. It's kind of a pain to keep opening VLC every time I want to use this thing, so maybe let's like write something that does that. I've always wanted to release a Python package on PyPy. Maybe I'll do that, and so on. So I was at that point. I moved the GitHub repository from the CH9329 keyboard to KVM-serial because I thought, oh well, you know, it'd be nice to support some other hardware as well, and that turned out to be wise. But GitHub, like when you move a repository, it just redirects. It's quite happy to redirect from your old one to your new one. So I wrote a GUI, threw together something in TK. I used that a little bit before as an undergraduate. This is going back a decade and a bit. Okay, yeah. So very simple thing. And I kind of set up this thing where you set up the parameters that you would otherwise put into the command line and click start. And then I discovered that it crashes on OSX because OpenCV is also using TK for its video window. So this is where we were when I did the first version of this presentation at the N8 RSE Away Day. I was kind of like there, and it was working. It was working. But yeah. So first attempt, TK into GUI v1. You don't want to see seg faults when you're running Python. It's an interpreted language. It's not a nice thing to be hit with. It turns out tkinter isn't thread safe. So I was sort of trying to run a TK window, and then OpenCV was launching its own thing from that thread, and that made Python very unhappy. And it turns out it's a bug. So what I did is I just literally used the GUI to set up the arguments and call control.py as a subprocess in a different shell, because now it's not in a thread, it's just a different shell, off you go. Wow, cool, okay, fine, I guess. But then I was like, well, let's, you know, we could go a bit further. So version 2, sort of remove my buttons in TK, just using the same script. But it might be nice to have the camera capture in there. So we put that in. Rendered that to the output in the main window. Added some nice system menu drop downs, so like file options, view menu, and then sort of did the mouse and keyboard capture within the GUI. So I wrote another implementation, which was like the TK implementation of keyboard capture, because TK has some interfaces for getting mouse and keyboard input. And it's nice because actually it only captures them when you've got the window focused. So when you defocus away to another app somewhere else, it just, you know, just sits there in the background and lets you work. But it was slow. It was so slow. It ran at 3 frames per second at 1080p, and that was on my 2023 M1 MacBook Pro using 100% CPU. Obviously, I was doing something wrong, and it turned out I was, because I was doing everything in sort of a single-threaded way. So I kind of took the decision at that point to throw away TK, get rid of tkinter, because I was kind of reading around it, and it seemed like PyQt had this QGraphics view thing, which would allow me to do like hardware accelerated rendering and proper threading. And hey, it works, and it was so snappy. I was like, wow, yeah, this is actually really, really cool. So yeah, little screen recording there of using Windows through the KVM tool from an OS X host, and yeah, it sort of allows you to do what you want to do, which is nice. Because I already had this like TK implementation, I went, you know what, can I just feed this to Claude? And it did some of the work. It took off some of the sort of overhead of porting that to Qt, because I've not used Qt before. But I will always say, when you use a language model as a text transformer for things, make sure you figure out what it's actually written. And it had done some things which were a bit strange and needed some fixing. So there's that. So that was where we are. So a little slide on like the affordances of these couple of GUI toolkits that I was using. So Qt5, yeah, multi-threading, hardware accelerated video capture. That's cool. You can sort of do frame request on demand, which gets rid of that whole UI stuttering issue. Whereas tkinter, you can kind of only do single-threaded on the main thread, and I was blocking the video, like the main loop, with my update calls to the video, and that's why it was so slow. I only figured this out like after I'd rewritten it, but yeah, I figured out why it was so slow. Nice thing about Qt is you get sort of this native UI components. The look and feel is the same across whatever you run it on, and yeah, it's sort of just a bit better in terms of widgets and how you lay out the application. But Qt you need to install as a dependency, so you don't get it for free. TK is part of the standard library to get it for free, so it's another dependency. So at that point, I went, oh, okay. So we've got something working that looks pretty nice. Let's stick a package up on PyPy. So I've been kind of version numbering as I was developing, and I've kind of gotten to version 1.4, and I released it as like version 1.4 on PyPy. And that sounds a lot more mature than it really is at that stage. Oh, 1.4, yeah, somebody's been several versions here. No, it should have been like version 0.1.x to really sort of indicate the level of reliability at that stage. But that's okay. But yeah, so now it's on PyPy. You can do like import KVM serial to use it and use all of the code out of it if you wanted to write something else. So yeah, it's quite nice. So a little bit of a chat about modern pip packaging, because I didn't know anything about this when I went to do this. PyProject.toml. I've always just been using like requirements.txt, stick my requirements in. I know how to install requirements.txt. That's fine. Oh, look, there's this whole like PEP 621 standard on how you can actually release software in Python and put all of your metadata in. And actually, you don't have to completely throw away your requirements.txt, because you can load it up inside PyProject.toml and just import the stuff and use it from there. And all of the kind of build system you declare in there. Yeah, really useful. That was something that I'll be doing again for other projects, because it made sort of the process of it much easier. Oh, and you can sort of put all your dev dependencies in there as well, which is nice. I suspect there's probably something to say about sort of support by insert Python package manager here, but I haven't put a slide together about that. So I've got my kind of declarative metadata in my project.toml. So then I thought, okay, so let's have a GitHub Actions workflow. Let's do some CI/CD. So I set it up so that anytime I did sort of git tag and git push tag, it would build. So run the unit tests, which I haven't talked about yet. Publish it to PyPy and release it on GitHub as a release. Yeah, so like I say, run the test suite first. Can you see that on there? Yes. Build and publish needs test. And then sort of test, build, publish, release. It was really nice doing PyPy builds on GitHub Actions, because doing it sort of manually from the terminal, I needed a lot of kind of token setup and stuff like that. It just works with GitHub. That's cool. I like that. So yeah, no sort of playing around with tokens and stuff, which is a nice little security benefit. So yeah, as you might have guessed, part of this I wrote some unit tests. I haven't done an awful lot of Python unit testing. I don't claim to be an expert on it, but I certainly learned some things. So I was sort of using patch, because I've got lots of imports, lots of dependencies. So using patch to patch the code and the modules to test. And it turns out there's a real ordering to this when you patch things, when you import things, which caused me some grief. You can even see on that screenshot there, I've got 6 skipped tests, even though there's 88 passed, because those tests were being naughty. So why? The patching problem. So if I do import KVM serial.kvm, that goes away, it runs that Python code inside that module, and that module has an import PyQt5 line in it. So if I import it there, by the time I've run my patch decorator later, sort of further down the line, it's already too late. I can't patch it because it's already been loaded and it's in sys modules. So you have to sort of patch things before you import them. So it quite often meant moving my import statements from the top of the file to inside my test methods, which I thought looked kind of weird. Don't really like that very much, but that seemed to work. So yeah, you can only kind of import what you're testing after all of your patches are active. And then I did some sort of cleaning of sys modules in teardown just to make sure that everything was removed after tests, so that each test would get fresh imports. So because there were kind of 3 major dependencies at this point, which were PyQt5, the serial module for the hardware I/O, and PyInput for input capture, each of those would cause issues when I tried to run it on GitHub Actions, because GitHub Actions is headless, and I'd always been running it on an environment with a desktop, so it was fine. It would go, oh yeah, cool, we'll import PyInput, that's great. Then you run it on GitHub Actions and it goes, there's no display manager here. You haven't installed X. I don't install X on GitHub Actions. That seems like a lot of workaround. So actually, you just need to mock the whole library, and any kind of calls to it, you mock, which is a lot of boilerplate, but necessary. Here's another thing I hit on when I was writing tests. I'd used is instance in my code in Python in places, which I'd kind of only done because my linter was complaining at me. And yeah, so Pylance would go, oi, you've done, you've sort of called this method with an object which isn't actually that object. So, okay, so I can just put that inside is instance in an if statement, put that under it, and then Pylons goes, oh, well, okay, so it must be an instance of that because you've called is instance. And then I tried to mock them, and now they're not instances of that object anymore. They are PyTest mock objects, and your is instance fails. So I kind of think like is instance can be a bit unPythonic in places because it breaks this idea of like Python duck typing, which is Python goes, if an object looks like it should be this object, it probably is okay to be that object, basically. So like if it walks like a duck and it quacks like a duck, it's probably a duck or near as good enough. It might be a goose, but that's okay too. So yeah, so is instance or has atta, I tried that as well. Those checks made the lint errors go away, but broke my tests. And then I was like, oh yeah, I just patched his instance. Don't try patching his instance. That's a bad idea. Use a cast, use a typecast, or just add a linter pin. Comment type ignore. So yeah. What else have I got on this slide? I only wrote these on the train, so so we've got like yeah. So here's a place where your lint is going to complain. So I've done like as part of my Qt code. I've got called menu bar.add menu file to get my file menu. And then I did like okay, file menu.add action. That might have been the line that was throwing the issue. Because my static type checker was like, oh, add menu file can return none. Okay, well, actually, that's never going to happen in practice, as far as I know. But to shut the linter up there, I've had to kind of cast it to Q menu. I don't really like that either. So if you sort of have better ideas about how to handle this sort of situation, which I found myself in, I would like to know. Okay. So what else did I do? I built some bits of hardware. So I was like, oh yeah, you know, this like little. It'd be nice just to kind of have these. So yeah, I built some hardware. I did some sort of like 3D modeling to get this. The tolerances are so tight when you get down to sort of this kind of scale of doing a USB stick thing. These don't fit together as well as I'd like, but it's okay for sort of a. I keep saying version 1, even though I feel like I'm sort of on version 5 of version 1, but never mind. Oh, and you can just stick STLs in PowerPoint. Who knew that? Drag and drop. Cool. So what's inside this? Oh, it's actually just 2 modules soldered together. So you can just buy USB-C serial modules on AliExpress, on eBay, and it was sort of directly pin compatible, or so I thought, with the CH9329. Apart from the 5-volt rail, which I was like, oh, that's okay. I'll just have this little yellow jump wire to jump my 5-volt rail over from pin 2 to pin 5. Yeah, don't do that. That's a really bad idea, because what you're doing at that point is your USB-C is feeding 5 volts backwards into the USB port, which is supplying 5 volts from your Raspberry Pi. Not a good idea. And I only sort of remembered that this was a thing when I unplugged the Pi from the power and it kept going. Oh no. Yeah, I'd watched a Big Clive on YouTube did a video on like backfeeding into he was talking about USB hubs which misbehave and backfeed 5 volts into your gadgets and break them. So yeah, danger, Will Robinson, don't do that. Okay. So yeah, pretty much at the end of the talk now. So kind of been doing this open source thing, sort of trying to push this little project. And I've got some open issues on my GitHub repo, things I haven't done, things I want to do. So it'd be really nice to just have some distributable executables that I can just sort of build for Windows, Mac, and Linux and give to people, or they can just download them instead of having to do like pip install. or your package manager. That would be nice. But there's sort of questions there around how do you actually bundle the libraries into that, which I need to sort of think about. Better documentation would be great. I kind of want to do like a GitHub Pages documentation site on there. That would be really good. Some sort of Sphinx generated developer docs. I still have a few unit tests which are marked as skip because just I'm so deep in like the mocking hell of what gets imported where and how do I patch that before it gets imported. I just and you have to skip these tests because otherwise they pollute the entire import state of Python, and then all of your other tests after them fail as well. So that's great fun. And then sort of some features and support of other hardware. So there's a couple of other chips that do this kind of thing. There's CH9328, which I think supports the keyboard bit, but not the mouse bit. So people might, you know, for the command line version, they might still want that. And then there's this sort of CH9350L, which also does HID emulation for keyboard and mouse, which could be nice to support to make this thing a bit more usable. So it's actually sort of like a serial KVM app rather than just the specific module KVM app. So yeah, that's the end. Thanks for listening. I'll be around all afternoon. If you do want one of these, you will have to buy your own like USB capture card to use with it because it's not much good without one. But I have like 4 of them. So if you really want one, come see me. You can have one. So yeah, the Git repository for the project is there, and these slides are on my website there. So that's it. So thanks very much. Oh, I could do a little bit of a demo, couldn't I? Could sort of run the thing. Where's my terminal? So yeah, at the moment, if you do Python -m KVM serial, you get a window where you can interact with something like a Raspberry Pi, which I've got plugged in. So yeah, and it's quite usable. Like there's a little bit of input lag. You can see the mouse kind of chasing itself. Last time I did this presentation, I did the presentation from the Pi, but I didn't tell anybody it was running on it until I was done. Yeah, now that I've got more slides, I was like, actually, I don't want to put a 28 meg PDF on a Raspberry Pi because it might complain. So yeah, put it safe. But yeah, so that's it. Thanks for listening, and any questions?
Thank you so much, Samantha. That was good fun. Do we have any questions? If anyone's online, if you want to dump it in the chat or stick your hand up, or anyone in the room.
Should I stop screen sharing?
Yeah.
Yes.
Yes, Jack.
So is the video now being captured by the same? It's all going through because at the beginning when you were hacking it together, you had 2 separate cables.
So it's still 2 separate cables. I mean, I don't know if I can sort of show the meeting owl here. If I put this over here on this screen, and then like that's stuck to the floor, unfortunately. Yeah, so it's still like
I'll just
yeah, there's like
right, I see it.
so there's a video capture card which is going to a separate USB-C port, and there's like this stick which is a different USB-C port. There is somebody online in the open hardware community who is like, hey, I've heard of this CH9329 thing. Wouldn't it be cool if you could just have one thing that did it all? So that's in the time where this has sort of been sitting. Other people have sort of started to realize this exists, and somebody's made like a little open source circuit board sort of you download the Gerber files and send them off to your insert PCB manufacturing company here, PCBWay or whatever. And then, you know, they can do pick and place and populate the modules for you. So that's pretty cool. So there are people working on the hardware side, and I want to get one of those. I want to make sure it works with this because that would be really cool.
Yeah.
There's a question online saying, is it allowed to be called Carpentries Offline? Because I know there was some dispute.
Oh, do they
at the
not
start
like
of
it?
At the start of it, apparently Carpentries weren't keen on it being called Carpentries Offline.
Were they
But
not?
they don't know whether that's resolved now or not.
I don't know. You'd have to ask Yonetta. She's still calling it that.
I guess that ties into the question I had slightly, which was, you've done the open source software for this, and you've got these nice green USB keys. Have you done anything to like open source the hardware side of this?
Well, there's not a lot of hardware to open source, I guess. If I just go back to the slide, I go back 1, 2. People online can't see this because I've stopped sharing the screen. But it's that picture of just the two modules soldered together. So it's open source insofar as you can look at that picture and see what you need to do. And like on the readme.md, there's like, oh, I don't have any particular hardware to recommend, but you can Google this and it will give you the right thing. You can also just buy a cable with two chips in. They're being sold now.
Chris?
So follow on and apologize, it's more on this.
Yeah.
I've been following some dude on Mastodon, who's actually the owner of my ISP, sort of A&A guys, who's in Wales. It's pretty cool, but he also dabbles in hardware. He's been making a audio voice recorder using the ESP32.
Yeah, cool.
So it clips onto your shirt button, whatever. And he was so he obviously has open hardware for the design. He sends it off to PCB loads. But he also uses their 3D printing service for the enclosure. And he's got the 3D CAD files, the enclosure, and he's been posting as he's been iterating on the design. So I noticed your one was square and had rails. And you're talking about the tolerances.
Yeah, it's too tight, really.
And the design he said it on got some sort of interlocking, still 2 halves of a shell, but it's not in the big thing. I think that's because he's hit exactly that same problem. So I'll send you a link to it.
Yeah, cool. Great.
You want one, don't you? You want one.
Well, again, it's more requirement. I was desperately trying to Google for it while we were talking, and I can't find the name. I only need to use this once a decade, but what I do is handy. So you've got the route of mocking the things because you don't have an X server and you don't have actions, but you can have headless X servers.
Yeah.
It's excellent B and C, but it's also X nest. Both of those I think are built on a lower layer thing. I just can't remember what it's called. Part of the main X distribution, and so you can. I've used it to get around licensing. The IDL used to have to click on the splash screen to get it to run. Run automatically, so I fire up a virtual X Windows, fire up IDL, use X do tool to dismiss it on the virtual screen.
Yeah. So I should clarify. You absolutely can run an X server on GitHub Actions. I just was stubborn enough that I didn't want to have that as a dependency because it's a fairly hefty download that runs every time you run your Actions workflow and gives you like an extra 50 seconds on the limited 50 seconds.
Having just had to build an action that installs Intel MPI, 50 seconds is nothing.
Yeah, sure, but yeah.
There's a question from Bryn, which was, do you currently support switching multiple inputs? So multiple PIs or switching between them in the GUI?
Oh, I see what you mean. So if you had like more than one of these things plugged in. So if I just share screen again. So it's sort of like partial support, I guess. Where are we? Yeah, I've totally lost like, aha. So you can do like, oh, I should share this on Zoom if the questions come off Zoom. So let's hit share screen again. And it's this one. Share. So you can do like, blow that up a bit. options, video device, and select a different video device. So it would just come up as another one of these. Because it's just webcams, it will display a webcam feed quite happily. But say you had like more than one of these things plugged in, they would all kind of come up in the video devices menu. What it doesn't support is multiple like different serial ports. So again, you'd be able to, like, if you had two devices plugged in, you could like switch the video device and switch the serial port. But there's no way of like grouping those. So that might be a nice feature actually. So you have like, oh, this is the group of serial port and video device that actually is this machine, and then here's my other serial port and other video device, which is another machine, and that kind of enable that. So yeah, you can do it, but you just have to do a lot of sort of manually switching ports in menus, which it's not always directly obvious what those ports do.
I also don't know where your Pi is getting its clock from.
Oh, it's not on a network at all. So this is, you know, part of the thing with Pi's. This is not my regular university. So I don't have login credentials for that network. I could set up EduRoam on it, but like that's kind of hard. You've got to do radius authentication. There's like typing out the WPA config thing for that. I've done it before. I probably have it saved somewhere, but it's a pain. So it's nice just to be able to talk to these things without having to connect them to a network.
Cool. Yes, Jack.
What is the like main bottleneck in terms of the input lag at the moment? Is it just the chip, or is it the software?
So my theory at this point is it's the cheapo HDMI capture cards that I'm using. I think if I bought one, like a nice one,
Right,
for
so
like
it's the
100
video
quid.
capture that's lagging, not the actual input.
Yeah.
It's output
So-
lagging.
People do, like game streamers online. Well, if they're playing a console game, they'll use some HDMI capture device to pull in their feed from their Xbox or PlayStation and then send it out through OBS and onto Twitch. So it's that exact principle. But the hardware to do that nicely without input lag is more expensive than my like Ugreen like cheapest possible thing that I could find on AliExpress. So I think that's where the input lag is coming from. I'm fairly sure it's not Qt, because that's the whole reason they rewrote it from tkinter into Qt, is to get rid of that input lag there, because it's hardware accelerated. So yeah.
Super. In which case, I think we'll finish up there.
Great. Thank you so much for having me.
Please just thank Samantha once again.